All right, welcome back to physics. And today I want to get you thinking about a few things that you touched, hopefully, with the lab last time. So thinking about speed and velocity and the distinction between displacement and distance traveled. So a subtle but really important concept to get down, especially early in the class. So we're going to use displacement a lot. So displacement is going to be a vector, which means that it has a direction. This line diagram that's shown here with the gentleman walking on top of it. So this is considered a vector for movement. So notice that as he moves to the right, that's going to move in the positive direction. If he was moved to the left, that would be moving in negative direction. So this is a distinction between displacement versus what you may be familiar with, the distance traveled, right? So if you walk around the block, then you have traveled some distance, but your displacement has been zero. So this is our first vector quantity. We're going to come across a number of things that have vectors associated with them. So we'll have a couple of ways of trying to indicate these, but this is the first one to really be careful about. So displacement is a vector, meaning that it has a number associated with it as well as a direction. Graphically, we'll show it as an arrow, and a lot of times we'll write in the direction it's headed, like to the northeast or southwest or 20 degrees from zero, wherever it might be. But it will always be including a direction with it. So first, to get our head around a little bit, so think about distance. So if you were to travel between classrooms and back again, right, you've traveled some distance, but your displacement is going to be less. So going from the math room, for the library, to the math room and back, right, the distance you travel is going to be, in this case, 16 meters. But if you travel to the library and math room and back, the displacement is zero. So be careful about it. So the displacement is going to be where you start, subtracted from where you end. So we use a couple of indicators for this. So traditionally we'll use X for horizontal displacement, Y for vertical displacement. So X is our variable that we'll use, and the initial position is to be X of I, and final position X of F. You don't have to use these. It's just some things that you come across and you'll see in this class. And my change in displacement is going to be my final minus my initial. It's going to be true for everything. So we're going to have final velocity and initial velocity. We'll have acceleration and be the same. Yeah, we'll get into other quantities, including momentum. We'll have a final and a change, which is always going to be final minus initial. So what you've been doing yesterday, hopefully, was taking a look at this buggy lab and trying to generate some position time graphs. Okay, so hopefully you get something that looks like this. Your buggy graph is a constant velocity, so it should be giving you a straight line. Remember, you need 7 data points to know if it's going to be a straight line or not. So you should hopefully get more data points than are shown here. Yeah, so this is a position time graph. In this class, we're always going to put time on the x-axis. So forget about independent and dependent. You may think that you're manipulating time, but you're not. So time is always going to be on the x-axis. If we have time, it's on the x-axis. If I said this 3 times now, time's on the x-axis. So on these graphs, we'll have position time graph, and it will indicate something. Right? This tells a story. Right? Somebody's walking away from their starting point. Right? So they're moving in the positive direction. They're getting further away at a constant rate. So we're going to have 2 things that we'll measure and calculate from this. So one is speed and one is velocity, and it is a subtle but important distinction for me. So when we take our total distance traveled and divide it by the total time, that's going to tell us the average speed that we've had on that trip. And we do this all the time if you're taking a car trip, right? So you say, well, I traveled 300 miles and it took me 6 hours, so the average was, what, 50 miles an hour. So this is a value that is based on speed and distance. So distance traveled is not a vector. That means that speed itself is not a vector. Velocity, on the other hand, is different. So velocity is a measure of displacement per unit time. Since displacement is a vector, velocity is also going to be a vector. It's going to have a direction. So right, you can travel at 20 meters per second forward, or you can travel 20 meters per second backwards. And that direction is going to be really important. And we're going to worry about this a lot over the next coming weeks, but it's important to recognize that speed doesn't have any direction, right? So you can travel any speed in any direction, but velocity is going to have a direction. It's a vector quantity. A couple of questions to think about. So how's the velocity of a race car going around a track 0 regardless of its speed? So there's a picture of the Indianapolis 500, and they go at, what, 230 miles an hour? Good grief, that's fast. But their velocity is 0. Think about it for a minute. Secondly, can an object have negative speed? Can have negative velocity? Briefly, so my displacement is my is going to be my final position, so and I subtract from that my initial position. So I start and end in the same place when I'm on a racetrack. So technically, my displacement is 0, and therefore my velocity, which is displacement per time, right, that's going to be 0 as well. So race cars have a very fast speed, but they have 0 velocity if they're going around in a track. Negative speed, so yeah, I can't do that. So you really can't have negative distance traveled, right? So either you travel some distance or you don't. So if you travel any distance, right, doesn't matter direction. So if you travel some distance, right, there's going to be a positive distance, and that'll be a positive speed. So speed can never be negative. Velocity, though, you can have negative displacement, right? So I can face backwards, right? So if my displacement, my positive displacement is going forward. If I walk backwards, right, I'm moving negative displacement, and I'll end up with negative velocity. So that's perfectly legitimate. We're going to look at over the next several weeks is going to be a lot of these position time graphs, and we'll add in these velocity time graphs. And so you want to remember a few things. So remember that velocity is the displacement per time. So this is the slope off of a position time graph. So a reminder that you calculate slope by rise over run. So position time graph, the slope is velocity, right? So my slope is meters per second. The unit is meters per second, and we're going to use that. So we're going to look at a number of these things. So we'll look at the position time graphs, and we'll look at velocity time graphs, and we'll look at acceleration time graphs, and try to get a head around. So these would be a little bit more complex than what we've just seen so far. So for position time graph, right, I can have somebody that goes at one speed, and then after some period of time speeds up, and now it's going faster again, positive direction. And then what happens here? Right, so they're standing still, right? Their position doesn't change over time, 0 velocity. And they may turn around and head back to where they started from. And so I may have a negative velocity. So these position time graphs are going to tell a story, and all of the graphs are going to tell a story of some motion. And we're going to try to get more comfortable with that over the next week in particular. Anyway, I hope that's helpful, and I look forward to seeing you hopefully soon in class. Take care. Bye.